We will start here now. Question number 5. C is called midpoint of AB. Prove that every line segment has one and only one midpoint. So you can see the figure. Now in this figure, A and B, AB is a line and we are taking the 2 point C and D. Let this point C and D, we take two midpoints of the line. We have to prove here. So firstly we are taking here C is midpoint of AB. If C is midpoint of AB, then AB is equal to twice AC. So AC is half of AB. Now we are in the second time. Now this time we are taking D is the midpoint of AB. So AB is equal to twice of AD. That means AD is half of AC. By Euclid's axiom, things equal to the same things are equal to one another. So 2AC is equal to 2AD. That means AC and AD are equal. So this is possible only when the point C and D coincide. Hence, we can say that hence every line segment has one and only one midpoint. So after this, we will start here now question number 6. So AC and BD are equal, then prove here AB is equal to CD. So you can see this figure, AC and BD are equal. So AC and BD are equal given in the question. So by Euclid's axiom, we want to subtract BC from both sides here. So AC minus BC is equal to BD minus BC. So if you can see here, subtract BC from AC, then you will get AB. And if you can subtract BC from BD, then you will get CD. So AB is equal to CD. Prove here now. Now the seventh question of this exercise. This is the last question of this exercise now. Why is axiom 5 in the list of Euclid's axiom considered a universal truth? Euclid's axiom 5 says that the whole is greater than the part. This fact is true for anything in any part of the world. So hence axiom 5 is considered a universal truth. So after this we will do exercise 5.2. This is the last exercise of this chapter now. In this exercise we have only the two questions. So firstly I will read the question number 1. How would you rewrite its Euclid's fifth postulate so that it would be easier to understand? If transversal intersect two lines such that any one pair of interior angles on the same side of the transversal is supplementary, then the lines are parallel. No need to make the figure here because they, very easily we can say that the two lines, if the transversal intersect the two lines such that any one pair of interior angle on the same side of the transversal is supplementary, the lines are parallel. We can also roughly we can make the two lines now. This line, this is the one line and this is the another line and this is the transversal. So if the sum of the two angles are 180 degree, then their line should be parallel. So no need to make the figure here now. So number 2 question. Does Euclid's fifth postulate imply the existence of the parallel lines? Explain now. So if a straight line L falls onto straight line M and N such that sum of the interior angle on the side of L is two right angles, then by Euclid's fifth postulate the line will not meet on this side L. Now the sum of the interior angle on the other side of L will also be two right angles. Therefore, they will not meet on the other side also. So the lines M and N will never meet and are parallel to each other.